Welcome back to another graphing trig functions lesson. Today we are going to be graphing cosecant and secant. And our warm-up is going to get us started with some of the things that we need to know about cosecant and secant. First off, what's the reciprocal of sine? Meaning the cosecant is 1 over sine, or 1 over those y values that we have. And the reciprocal of cosine will then be secant, 1 over x. And tangent and cotangent are reciprocals, although we're not graphing them yet. Just a quick little review of those. All right, our next slide says, what are some of the things you remember about the sine and the cosine graphs? Hopefully what first comes to mind is all of those characteristics that we would write: the midline, the amplitude, the period, which is 2 pi over b, the boundaries where I begin and end with those 5 critical values, those x values, and finally that increment. So when we take our period and divide it by 4, that gives us the increment to add from left boundary to right boundary. And then actually speaking about the sine and the cosine graphs, sine starts and ends on the midline. It only has 1 maximum and 1 minimum, so 2 extrema points. One has to be a max, one is a min, and there's 3 points that are on the midline. Okay, and then for cosine, it starts and ends at an extrema. So you're going to have 3 different extrema, either 2 maximums and a minimum if it's a positive cosine, or 2 minimums and a maximum if it's a negative cosine. And then the remaining 2 points will be your midline points. So we're going to use all of that same information from sine and cosine to help us graph their reciprocals. So here's another quick little thing. We're going to do all that same stuff again. In order to graph secant and cosecant, we need the midline, amplitude, period, boundaries, those 5 critical values. Don't forget the increment as well, so that we can graph secant, which is the reciprocal of cosine, and cosecant, which is the reciprocal of sine. We're going to do all that stuff the same. We're even going to plot the same points, but we're not going to connect the points. Don't connect the points. We do other things with them to get these graphs. So all of the points that we have for secant and cosecant are now going to become vertical asymptotes. These are places within the domain of those functions that the functions will be undefined. And then any of those maximum points and minimum points, we're going to sketch them as a parabola using that particular point as its vertex. So points that are above the midline, so those maximums, become a little baby parabola that opens upwards, and then the points, the midline points, or excuse me, the minimum points below the midline become what I call baby parabolas that face downward. Okay, so first example, here we go. Okay, our first example is y equals 4 cosecant of the quantity x plus pi minus 3. And I first want to make note that cosecant is the reciprocal of our sine function. So we are going to graph all the points like sine and then change it after that. All of the other stuff is the same. The amplitude is still that leading coefficient 4. The midline is still what's added or subtracted to the back end, y equals -3, which you can go ahead and graph. The period is 2 pi over b, so that'll just give us 2 pi. There's no horizontal stretch or shrink. The boundaries are found by setting everything in parentheses equal to 0 for the left boundary and equal to 2 pi for the right boundary. You should solve to get your boundaries to be -pi to +pi. Okay, and then our period is the increment that we add to get from -pi to +pi is the period divided by 4. So 2 pi over 4 or pi over 2 if you'd like to write it like that. So I'm starting at a critical value of -pi over 2 and adding, -pi and adding pi over 2, which will get me -pi over 2. Add it again to get me to 0, and so forth. So my points will be, the x critical values are -pi, pi over 2, 0, pi over 2, and pi. And you'll notice they're equidistant on each side from 0, so I counted over 2 spaces to represent pi over 2. So there's a -pi over 2, another one, a +pi over 2, and another one. Just be careful of that spacing. All right, our points, again, are just like the sine points. So we are going to start on the midline, use the amplitude to go up 4 for the next point. Come back to the midline, use the amplitude to go down 4 for the next point, and then finish on the midline. Now, that looks like the sine curve. If we trace it, we see that sine curve. However, it's the reciprocal. So this first half is going to do the reciprocal through that maximum point. The second half will do its reciprocal through that minimum point. Okay, so all of our midline points become asymptotes. Points above the midline that were maximums of sine become a parabola face up. Points below the midline that were the minimum of sine become another parabola face down. That does change our range because you'll notice none of the stuff in between the minimum and maximum values where sine is drawn is part of the function. So our range is split from negative infinity to -7, and then union 1 to positive infinity. Great job with the first one. Let's try another. Okay. Okay, our next one is y equals 2 secant of the quantity x minus pi plus 1. This time our function is secant, that is the reciprocal of cosine. So we are going to plot points for cosine and change it into our secant graph. Here we go. Amplitude 2. Midline is a y equals 1. Sketch that line. The period is 2 pi over b, which is just 2 pi. The boundaries, everything in parentheses equal to 0 and everything equal to 2 pi, giving us boundaries of pi and 3 pi. So we have a shift to the right. We're going to have to make sure that when we use our increment, which is pi over 2 or 2 pi over 4, when we add that from one place to the next, that we get correct spacing for this guy. So we're going to go ahead and put a point for 0, mark a distance to be pi over 2, and then pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. So we're actually going to skip these first points up here, totally fine, and then start at x equaling pi. This is a cosine function, so we have to start at the maximum because it's positive. So at pi, we will go up 2 units from the midline, hit the midline, go down 2 units from the midline, back to the midline, and then back at that maximum value. Okay, so just like we did for the other one, any points that are on the midline become vertical asymptotes. Points above, which were originally maximums of cosine, are now parabolas that open up. Make sure that you either only sketch the half of it that you have for the point, or you stay within your boundaries for that next asymptote where it would be. And then points below the midline, which were the minimum of cosine, now become a parabola down. When you do the range, you'll go from negative infinity to that original minimum value, so negative infinity to -1, and then use the maximum of cosine from 3 to positive infinity. Great job. All right, we've got a couple more to do, and here we go. Example 3, y equals -2 cosecant of 2x plus pi plus 3. Again, this is the reciprocal of our sine function. Amplitude's the same, midline's the same. Once you know it, graph it at y equaling 3. That amplitude's 2. Your period for this one is changed. There's a 2 in front of the x, so our period 2 pi over b simplifies to give us pi. So it's half the distance it would normally be. Boundaries are found the same by setting everything in parentheses equal to 0 for the left boundary, equal to 2 pi for the right. And when you solve, you will get negative pi over 2 to positive pi over 2. Take your period, which is pi, divide it by 4 to get your increment, which means we need to count by a pi over 4. So I'm to the left and the right. So at 0, I need to count by pi over 4 to get over to negative pi over 2, and count by pi over 4s to get to positive pi over 2. Those critical points will be negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Cosecant is the reciprocal of sine. Start with your first point on the midline. Amplitude is negative, so go down. Back to the midline, up, and then back to the midline. All of your midline points become asymptotes, vertical asymptotes. Points above are parabolas that open up. Points below are parabolas that open down. The range, use those max and min points, and it's everything but that section. Negative infinity to 1, union 5 to infinity. Okay, we have one more and then we are done. Yay us. Y equals negative secant of x minus 2 pi minus 3. Amplitude is 1. Even though there's a reflection, that's okay, we still write 1. Midline is y equals negative 3. Graph that line. Period is just 2 pi. There's only a 1 in front of that x. The boundaries, everything in parentheses equal to 0 and 2 pi for left and right boundaries. When we solve, we'll get boundaries of 2 pi to 4 pi. We're going to have to skip a whole bunch of stuff over here from 0 to start over here at the 2 pi. Our increment is still that period divided by 4, 2 pi over 4 or pi over 2. So let's count by pi over 2s. We'll start at 0 and then count pi over 2, pi. 3 pi over 2, 2 pi. 5 pi over 2, 3 pi. 7 pi over 2, 4 pi. You only need the critical points from 2 pi to 4 pi. Okay, and trying to space them out didn't work, which is why they are so close together for this example. Secant is the reciprocal of cosine. So we're going to start at, in this case, a minimum value. So at 2 pi, go down a unit for that first minimum, midline max, midline back to the minimum. We're not connecting those points. We're sketching vertical asymptotes through the midline points. Baby parabola above, little baby parabolas face down for anything below the midline. And our range for this one is from negative infinity to negative 4, union negative 2 to positive infinity. Great job, guys. I'm proud of you for sticking it out. Have a great day.